Good morning, children. Today we are going to see a new chapter in physics, chapter 12, electricity. First, what is electricity? In your houses, you have fan, TV, fridge, mixie, grinder, water heater. Everything needs electric power to operate. When you put the switch on, they operate. So when you switch it on, the fan rotates. When you switch it off, the fan stops rotating. So what is happening there in such a way that the appliances are working when you switch on? That is because of the electricity. So I can define the electricity as flow of current or flow of electrons. So in our houses, all the appliances are connected to the electric board which gives us the current supply. When I switch on, the current flows and it enables the fan or the bulb to glow. The fan rotates. Right? Now, there are two ways of defining what is electricity. One is flow of current and the other one is flow of electrons. What is meant by electrons? We have seen in the refreshing classes that all the elements are made up of atoms. Atoms are the smallest units. So when you look at the structure of an atom, you will have the nucleus in the center and surrounded by the orbits. In each orbit you will have the electron, and in the nucleus you will have the protons and neutrons. So the proton, neutron, electron, all these things are nothing but the charges. Okay. Proton is a positively charged particle. Electron is a negatively charged particle. Whereas neutron is no charge or neutral charged particle. Okay. So this is what the charges present in an atom. This is related to the chemistry. But now in physics, while the current is flowing in electricity, what is the use of electrons? That is, the electric current is also having the charged particles, that is protons and electrons. So all the electric charge will be of two types as proton or electron. Positively charged particle means proton, negatively charged particle means electron. So when I mean it as the flow of current means the charges are only flowing, these charged particles are only flowing and giving us the current supply. Understood? So the current we cannot see, but it means the flow of charges. This charges, that is the electric charge, is of two types. Proton means positive charge, electron means negative charge. Understood? But how does this charges flow? Simply, if you have a fan means, and if you have a switchboard, if you switch it on, will it rotate? No, right? We need to give the proper wire connections. Why are we giving the wire connections? What is present inside the wire? The wires which are all given as connections to the appliances are made up of copper. Okay, copper is a metal which allows the passage of electric charges to them. So all the metals will not allow the electricity to flow through them. But certain metals like copper, silver will allow the electricity to flow through them. Since silver is expensive, it is costly, we don't use silver wires. We use copper wires. So if you are building a house or if you see anyone building house, then when there is electric connections given, you go have a look at the wires used there. you will have the copper wires, because they allow the electric charges to flow through them. Will a plastic object conduct electricity? Conduct means will it allow the flow of current through it? So this is a plastic pen. If I give connection to it, will it allow the current to pass through it? No, right? Because it doesn't have the ability to allow the charges to flow through in it. Whereas copper has the ability to allow the passage of electric charges, that is the current supply through it. Okay, so that kind of materials which has the ability for the current to pass through are called by the name as conductors. What is it? Conductors. Conductors mean they are materials which has the ability to allow the flow of charges or current through it. Water is a conductor. Human body is a conductor because they have the potential to allow the charges to pass through them. We eat food. In the food, water is there. So human body has 60 to 70% of water content in them. So human beings are also conductors. Copper is a conductor. Silver is a conductor. Plastic is a conductor or not? Plastic is not a conductor. So what do I call the objects which are not conductors? The opposite of conductors is insulators. The opposite of conductor. It means insulators or material which will not allow the flow of current through them. What can be the examples for insulator? Like plastics, wood. Okay. So conductors means the materials which allow the flow of current through them, and the opposite of it is insulators. Insulators will not allow the current to flow through them. Their examples would be plastic and wood. So clear that electricity means it is the flow of current. For this current to flow, we need the electric charges. They are of two types, protons and electrons. Protons means positive charge, electrons means negative charge. These charges only are flowing through the materials and we get the current supply to the appliances in our house. So I call the materials which have the ability for the flow of charges as conductors. Example, copper, water, silver, human beings. Why are we not using silver wires? Because silver wires are expensive. So we use copper wires in our houses for electric connections. And the opposite of conductors is insulator. Insulators means the materials which will not allow the flow of current. Example is plastic and wood. So now what did we see? We saw how the current flows. It needs a material, that is the conductors, for the flow of current. Now look at this. This is a wire. Okay, just an example. I had two ends of the wire as A and B. So in this wire, it is a copper wire. Let us consider as a copper wire. So copper wire will allow the flow of charges through them. So it will allow the passage of current, that is electric current, through it. Now in this thin wire, copper wire, how is the current flowing? In what direction it flows? Okay. So how to identify that is, I am keeping the end A of the wire to the positive terminal of a battery. Okay, we need a battery for the current also. So I'll come that in detail. But before going in detail, you should first know the direction of current. So one end of this wire I'm connecting to the positive end of a battery, and the negative end of the battery is connected to the other end of the wire. Okay, so a wire is taken, there are two ends A and B. Each end I'm connecting to each positive and negative terminal. Okay, so in this connection, how will the current flow? In what direction does it flows? The current flow will always be from the positive terminal to the negative terminal. Okay? Okay. So, we don't want to think as in the large scale electric connections and all, like how a fan is connected to the meter board in your house, and how do you get the current supply. Don't want to go too deep. Let us consider with a very small electric circuit. That is, you're having a bulb. You wanted a small bulb. Okay, you wanted this bulb to glow. So what and all you need? You need switch, you need wires for connections, isn't it? And you need the bulb, which is the main important one. And what else you need? Just by giving connections to the switchboard with the wire alone, the bulb will not glow. You need a very important component, that is your electric cell. You could have seen this in your toys and all. Only when you put the electric cell, it starts to play. You have seen a torch. Do you have a torch in your home? Torchlight? When you switch on, the torchlight glows because you have inserted the electric cell inside it. Your TV remote will have the electric cell. Only if the electric cell is in working condition, the remote will operate, right? So this electric cell nowadays we have in the markets like Duracell, everyday cells. Okay, so this electric cell is what I have drawn here. In an electric cell, you will have the chemicals inside, such as lithium. Okay, so you will have this chemicals filled inside the electric cells. That is why the electric cell has the power to give current supply. Okay, so when you just insert an electric cell to a remote, it starts to operate. How come it is possible? It is because of the presence of the chemicals filled inside the electric cell, that is the lithium. Once the chemical is completely over, the cell will not be in working condition. So what do? We replace it with a new cell for the remote to operate. Isn't it? This you would have definitely done in your house. So understand that the electric cell has chemicals inside them such as lithium. Until the chemical is inside, it will operate. Once the chemical is used, it will not be in the working condition and we have to insert a new cell for the working condition. Okay, now, so in your remote you will have the slot for the electric cell to be inserted. At one end you will have a spring and the other end you will have this side spring. You cannot insert the electric cell in the same, like this itself I cannot insert it on the two slots. I will insert one cell like this and I will turn it upside down and I will insert the other cell like this. So one cell I will insert it like this and the other cell I will insert it like this. Why am I doing so like that? Even your slot will be in that kind of fitting only, in your remote and all, or in the torch lights also. That is because the electric cell will have the two ends, that is this end and that other end, are considered as the terminals. Terminals is nothing but the other name of end. Okay, terminals. Terminals means end. So this is the positive end and this is the negative end. The flat side of the cell will be the negative, and you will have a small projection on the other side of the cell, that is the positive. Okay, so we saw already here, right, that in a wire the current flows from positive to negative end. So this is also a cell which has the chemicals inside them for the flow of current. So here, how does the current flow, in what direction? As usual, from positive to negative. So you should be first clear with which is the positive end and which is the negative end. The projected one is your positive end and the flat end is your negative end. Okay, so the current will flow from the positive to negative. So that is why I am turning the cells upside down, and in the opposite side I am inserting it in the remote slot. So you will have a spring here. One positive end will be connected to the spring, and this side also the positive end, that is the projected end, will be connected to the spring. Okay. So what did we see today? We saw that the electricity is the flow of current, which is nothing but the flow of charges. The charges are of two types, that is the electric charges of two types, positive and negative. Proton is the positively charged electric charge. Electron is a negatively charged electric charge. And for this current to flow, we need the wires. The wires is made up of copper. Silver wire is also the best one, but we don't prefer it because it is quite expensive. We always use copper wires. So such materials which conduct electricity are called conductors. Conduct electricity means which allows the flow of current through them. Okay, insulators is the opposite of conductors. It means they will not allow the flow of current through them. Example, plastic and wood. And next we saw, in a wire, how does the current flow? In what direction does it flows? It flows from the positive end to the negative end. Okay, then we saw a very small electric circuit, that is our example cases we want a bulb to glow. So for the bulb to glow, I need the bulb, wires, that is the connecting wires, switch, and the electric cell. This electric cell we have in the markets, and we have also seen in the torch lights, remotes and all. Okay, the electric cell is filled with the chemicals that allows the flow of current, that produces the current. So the chemical is nothing but your lithium. In an electric cell, the projected end will be considered as the positive terminal, and the flat end of the cell will be considered as the negative terminal, in such a way that the current always flows from the positive to the negative terminal. Okay children, so if you have any doubt in this, kindly contact me. The remaining we can continue in the next class. Thank you children.